Another joke. You guys want to hear a morning joke?
Yes.
Okay. Don't read, Sylvie. What are the strongest days of the week? Saturday and Sunday, because the rest of the days are weekdays. They're not strong, they're weak. When graphing relationships in physics, especially when you're dealing with vectors, we do need to keep into account what direction means. And for our purposes, it will either mean plus or negative. In today's experiment, you can see that the giraffe will be moving towards the right, and right is typically considered a positive direction. Therefore, if the giraffe was moving towards the left, he would be moving in a negative direction. Now, position time graphs will always have that focus of direction as well as the size of the movements taking place. So you're going to see a little video right after this clip or this picture showing the giraffe in motion, and then we'll clearly see the kinds of data that will be produced, both in the graph form, which will be our focus in this whole lesson, and in the tabular form. We will also be able to do a calculation of the velocity of the giraffe based on the data that we'll see. So that's a pretty quick experiment the giraffe just underwent. But the point here being is that the giraffe started at the 0 meter reference point, and only moved towards the right of that 0 meter reference point. So all the position measurements are positive as a result. Now, the graph reflects that in the way that it's going, but also the table of data on the right-hand side shows that as well. Now there's a slight error there for our first data point at negative 0.01. That's pretty much the 0 that I just referred to. So the thing is, for us to be able to do a hand-drawn graph, which is our focus here, we'll need a couple of data points. This could be one of them, the 0.08 seconds and the negative 0.01 or roughly 0 meter reference point. So we'll need another data point to compare this one to, and then we'll be able to do a calculation of velocity. So at the end of the experiment, the giraffe traveled roughly 2.1 meters to the right, and it took the giraffe 1.68 or so seconds to get there. Now, we have two data points that we can put into our slope formula, which is the next thing we'll do. So when you solve for the slope of a position time graph, you are getting the average velocity. Slope is rise over run. Specifically here, our rise is our change in our position, or our displacement, d2 minus d1, and our run is our change in time, t2 minus t1. Similarly, now the numerator is the displacement that has all the direction information attached to it. So anyway, to carry out our calculation, on top we have our final distance of 2.1 meters. Subtracted from that is our initial position, I should say, of negative 0.01 meters. That's all divided then by 1.68 seconds subtracted by 0.08. You can see time is never a vector quantity, hence it's never going to be a negative value. You end up with 1.31 meters per second as your answer. Since that's a positive value, we know then that the object was moving towards the right. Let's look at the same experiment but with a different reference point. The reference point's now been shifted where you can see the y meeting the x in the photo. So it's a good distance away from the giraffe. The giraffe, most importantly, is to the left of the reference point, and by the end of the experiment, it will never have gone towards the right. So all of this will be to the left of the reference point, and we'll do some analysis afterwards. So that very fast experiment again produced us these results, but the results are different because again our reference point changed. Now we can see that the giraffe, or the object in motion, was never to the right of the 0 meter reference point. It was always to the left, and it started at negative 1.74 or 1.74 meters left of the 0 meter reference point. It then ended up at roughly the 0 meters reference point at the end of this experiment. Now, we'll do our little calculation, but let's examine again the initial position at negative 1.74 at the time of 0.08 seconds. So almost 0 seconds is where we would have started this. So almost 1.2 seconds later, the object ends at negative 0.03 meters, which is 0.03 meters left of the 0 meter reference point. So pretty close to the reference point itself. But the whole point is that we do now have a couple of data points, our D2, D1, and our T2 and T1 to put into our slope calculation and see what the average velocity is in this case. So our slope calculation reveals again the average velocity of this giraffe in motion. That the only difference here, of course, is our data points. We started at negative 0.174 meters, our D1, and ended at negative 0.03 meters, our D2. So when you put that into your formula, that's your numerator. Negative 0.03 meters subtract negative 1.74 meters. Now, that again is our displacement, or the change in position that the giraffe underwent, and it was always in the left side of that 0 meter reference point. Time again, not a vector quantity. We just need our final time of 1.28 and subtract from that the initial time that we did this experiment at, which was 0.08 seconds. Gives us a value of 1.43 meters per second, slightly higher than our previous result, but most importantly, and the connecting thing here, is that the animal is still moving towards the right, which is indicated by the slope calculation, but also from the graph itself. If you see it, you can see the similarities between those two. Beautiful.
Good job.
Okay, so let's look at a rolling drum instead of a giraffe. Now, the reference point, you can see clearly, is close to the drum right now. So the drum will be traveling towards the right. You'll see the data on the next slide. So the data that was created was this, and you can see the initial time at 0.07 coincided with the initial position at 0.00, right on the reference point itself. So the final position reached by this rolling drum was 1.66 meters right of the 0 meter reference point at a time of 1.53 seconds. So try the velocity calculation with the data that you saw in the last two clips, and you will get what you see right here. Velocity of 1.13 meters per second to the right. For this little experiment, you're going to see Nora push the drum from where she is to the right of the reference point back towards the reference point. So that's going to be a little different. This is the first negative slope we've seen in our position time graphs for this whole video. Our time, in this case, that it started at was 4 seconds, and the object had an initial position of 0.87 meters right of the 0 reference point. Our final position is a negative 0.07 meters, so just slightly left of the 0 meter reference point at a time of 5.83. When we apply the average velocity formula, we do get an answer that's negative 0.51 meters per second, which of course in this whole video meant to the left. Now it was clear that the drum was rolling to the left, and it's also clear from the calculation that it was also moving to the left, the negative sign. So here's a fairly straightforward one you can try on your own. All the data will follow. And for this one, with the reference point kind of there in the middle, it will be a little bit different, but the data should allow you to still get good calculations.